Hello everyone. Suppose you want all gray code values, not just convert one number. Can ARM generate the entire gray code sequence automatically? With just a counter, a shift, and XOR, the answer is yes. This program generates first 16 gray code values in sequence. Before understanding this code, let's see if it has any errors. No errors, so we can go ahead with debugging. Now we'll see what's happening here. Area is nothing but an assembler directive which instructs the assembler to define a section of memory to store this information. Gray sequence is the name given to that section of memory. Code indicates this information is nothing but actual ARM instructions. Read only indicates that any modification should not be carried out on this particular code during runtime. Entry indicates where exactly execution starts. Execution starts at the very first label that is seen right after the entry assembler directive. Start, loop, stop are nothing but labels. End is again an assembler directive which indicates the end of source file. In the very first step, arg0, which is acting as our counter here, is stored with the value 0. This is our binary counter whose initial value is updated as 0. Inside the loop, the very first step that we see is the content of arg0 is right shifted by 1 bit position and the result is stored in arg1. The original value of arg0 is 0, so the result stored in arg1 will also be 0. Okay, because right shift of 0 will be nothing but 0 itself. Then we are performing XOR between the original content of arg0 and arg0 content right shifted by 1. If you remember, this is the exact method we use to obtain gray data from binary data, that is binary content XORed with the same content right shifted by 1. Okay, and the result of that is now stored in arg2. As you can expect, in this particular step result will be 0 itself, because even in the case of gray code the very first data we obtain is 0 itself. Now we are incrementing arg0 and we are comparing if arg0 is 16. The reason we are doing this is we want to generate the first 16 gray code. If you want to generate more values, you have to just increase this number here. So here what happens is arg0 minus 16 is done. So based on the result generated, the CPSR is updated. Right now Z is 0. So this branch will occur because not equal condition is true. As soon as arg0 is equal to 16, it will set Z flag as 1, and because of which this particular conditional code will be false, and that leads to the breaking of the loop and the jump to this particular label. So as of now Z is 0, because of which we branch back to this particular instruction. Let's see that happening. Okay, so again now you can notice that arg0 is actually 1, which supposed to be shifted right by 1 position. If 1 is shifted right by 1, the result is 0. So that result will be stored in arg1, and now when this content, that is 1 and 0, are XORed, the result we obtain is 1 itself. Okay, again arg0 is incremented, compared with 16, and we branch back to the loop. From now onwards you will start noticing the difference. arg0 is currently 2, but when you shift it right by 1, the answer you get is nothing but 1 itself. So now in this step, when we perform XOR operation between 2 and 1, the result is nothing but 3, and that is stored in arg2. So you can notice the deviation between the binary code and the gray code. First two values are same, 0 and 1, but instead of 2, the third value generated is nothing but 3. Next, the same set of steps keep repeating. Because of which you can see your desired sequence of gray code appearing in register R2. Once the gray code for F is generated, we can see that currently R0 is actually 16. So the comparison will make Z set as 1, and hence this loop will break and we will reach the infinite loop stop branch to stop. That's all about this code.